Micronutrients are nutrients required by humans and other organisms throughout life in small quantities to orchestrate a range of physiological functions. For people, they include dietary trace minerals in amounts generally less than 100 milligrams day, as opposed to macrominerals which are required in larger quantities. The microminerals or trace elements include at least iron, cobalt, chromium, copper, iodine, manganese, selenium, zinc and molybdenum. Micronutrients also include vitamins, which are organic compounds required as nutrients in tiny amounts by an organism. Public health initiatives for humans. At the 1990 World Summit for Children, the gathered nations identified deficiencies in 2 microminerals and 1 micronutrient iodine, iron and vitamin A, as being particularly common and posing public health risks in developing countries. The summit set goals for elimination of these deficiencies. The Ottawa-based Micronutrient Initiative was formed in response to this challenge with a mission to undertake research and fund and implement micronutrient programming. As programming around these micronutrients grew, new research in the 1990s led to the implementation of folate and zinc supplementation programs as well. Priority programs include supplementation with vitamin A for children 6–59 months, zinc supplementation as a treatment for diarrheal disease, iron and folate supplementation for women of childbearing age, salt iodization, staple food fortification, multiple micronutrient powders, biofortification of crops and behavior-centered nutrition education. Salt iodization. Salt iodization is the recommended strategy for ensuring adequate human iodine intake. To iodize salt, potassium iodate is added to salt after it is refined and dried and before it is packed. Although large-scale iodization is most efficient, given the proliferation of small-scale salt producers in developing countries, technology for small-scale iodization has also been developed. International organizations work with national governments to identify and support small salt producers in adopting iodization activity. In 1990, less than 20% of households in developing countries were consuming iodized salt. By 1994, international partnerships had formed in a global campaign for universal salt iodization. By 2008, it was estimated that 72% of households in developing countries were consuming iodized salt, and the number of countries in which iodine deficiency disorders were a public health concern reduced by more than half from 110 to 47 countries. The Network for Sustained Elimination of Iodine Deficiency is an international network of UN, not-for-profit, scientific and industry organizations, with the mission to promote and support collaboration in efforts to ensure adequate iodine consumption, primarily through the achievement of universal salt iodization. Nicholas Alapui chairs the network. Vitamin A supplementation. In 1997, national vitamin A supplementation programming received a boost when experts met to discuss rapid scale-up of supplementation activity, and the Micronutrient Initiative, with support from the Government of Canada, began to ensure vitamin A supply to UNICEF. In areas with vitamin A deficiency, it is recommended that children aged 6–59 months receive 2 doses annually. In many countries, vitamin A supplementation is combined with immunization and campaign-style health events. Global vitamin A supplementation efforts have targeted 103 priority countries. In 1999, 16% of children in these countries received 2 annual doses of vitamin A. By 2007, the rate increased to 62%. The Micronutrient Initiative, with funding from the Government of Canada, supplies 75% of the vitamin A required for supplementation in developing countries. Double fortified salt. Double fortified salt is a public health tool for delivering nutritional iron. DFS is fortified with both iodine and iron. It was developed by Venkates Manna, Executive Director of the Micronutrient Initiative, and University of Toronto Professor Levent Diozidi, who discovered a process for coating iron particles with a vegetable fat to prevent the negative interaction of iodine and iron. In India, Tata Salt Plus, priced at an economical rate of Rs20 per kg, is an iodine plus iron fortified salt, developed by the National Institute of Nutrition, Hyderabad through double fortification technology. This technology was offered to Tata Chemicals under a long-term MOU after due studies on bioavailability across the population strata conducted and published by NIN. It was first used in public programming in 2004. In September 2010, DFS was produced in the Indian state of Tamil Nadu and distributed through a state school feeding program. DFS has also been used to combat iron deficiency anemia in the Indian state of Bihar. In September 2010, Venkata Manna was named a laureate of the California-based Tech Awards for his work in developing double fortified salt. Micro-enriched fertilization. The returns of applying micronutrient-enriched fertilizers could be huge for human health, social and economic development. Research has shown that enriching fertilizers with micronutrients had not only an impact on plant deficiencies but also on humans and animals, through the food chain. A 1994 report by the World Bank estimated that micronutrient malnutrition costs developing economies at least 5% of gross domestic product. The Asian Development Bank has summarized the benefits of eliminating micronutrient deficiencies as follows. Along with a growing understanding of the extent and impact of micronutrient malnutrition, several interventions have demonstrated the feasibility and benefits of correction and prevention. Distributing inexpensive capsules, diversifying to include more micronutrient-rich foods, or fortifying commonly consumed foods can make an enormous difference. Correcting iodine, vitamin A, and iron deficiencies can improve the population-wide intelligence quotient by 10 to 15 points, reduce maternal deaths by 1/4, decrease infant and child mortality by 40%. And increase Euro unregistered trademark's work capacity by almost half. The elimination of these deficiencies will reduce healthcare and education costs, improve work capacity and productivity, and accelerate equitable economic growth and national development. Improved nutrition is essential to sustained economic growth. 5 Micronutrient deficiency elimination is as cost-effective as the best public health interventions, and fortification is the most cost-effective strategy. Addressing zinc deficiencies through zinc fertilization. Experiments show that soil and foliar application of zinc fertilizer can effectively reduce the phosphate-zinc ratio in grain. People who eat bread prepared from zinc-enriched wheat show a significant increase in serum zinc, suggesting that the zinc fertilizer strategy is a promising approach to address zinc deficiencies in humans. Where zinc deficiency is a limiting factor, zinc fertilization can increase crop yields. Balanced crop nutrition supplying all essential nutrients, including zinc, is a cost-effective management strategy. Even with zinc-efficient varieties, zinc fertilizers are needed when the available zinc in the topsoil becomes depleted. Micronutrients for plants. There are about 7 nutrients essential to plant growth and health that are only needed in very small quantities. Though these are present in only small quantities, they are all necessary. Boron is believed to be involved in carbohydrate transport in plants. It also assists in metabolic regulation. Boron deficiency will often result in bud dieback. Chlorine is necessary for osmosis and ionic balance. It also plays a role in photosynthesis. Copper is a component of some enzymes. Symptoms of copper deficiency include browning of leaf tips and chlorosis. Iron is essential for chlorophyll synthesis, which is why an iron deficiency results in chlorosis. Manganese activates some important enzymes involved in chlorophyll formation. Manganese-deficient plants will develop chlorosis between the veins of its leaves. The availability of manganese is partially dependent on soil pH. Molybdenum is essential to plant health. Molybdenum is used by plants to reduce nitrates into usable forms. Some plants use it for nitrogen fixation, thus it may need to be added to some soils before seeding legumes. Zinc participates in chlorophyll formation, and also activates many enzymes. Symptoms of zinc deficiency include chlorosis and stunted growth. Micronutrient deficiencies in crops. Micronutrient deficiencies are widespread. 50% of world cereal soils are deficient in zinc and 30% of cultivated soils globally are deficient in iron. Steady growth of crop yields during recent decades compounded the problem by progressively depleting soil micronutrient pools. In general, Farmers only apply micronutrients when crops show deficiency symptoms, while micronutrient deficiencies decrease yields before symptoms appear. Some common farming practices contribute to widespread occurrence of micronutrient deficiencies in crops by decreasing the availability of the micronutrients present in the soil. Also, extensive use of glyphosate is increasingly suspected to impair micronutrient uptake by crops, especially with regard to manganese, iron and zinc. See also: List of micronutrients, macronutrient, dietary mineral, manganese deficiency, John Mortvedt, soil scientist focused on micronutrient fertilizer, references. External links.